Hello, geometry. Welcome to lesson 10.1 on arcs and sectors. 3 videos coming up here to start our topic 10 on circles. Circles, for some reason, is a difficult part of the OST for students. So again, make sure you really focus and pay attention. A lot of this stuff is new, right? So you have a base understanding of what a circle is, but all this new vocab can be intense. So just do your best this topic. So let's talk about what we do know about a circle, right? So I think you know what a circle looks like. Typically it has a center, we'll call it C. Now you might not know that we name a circle with that center, so this would be called circle C. Now the first thing I want to draw is a diameter. So a diameter goes all the way across a circle through the center. So AB. So over here, AB is a diameter. And then I'm going to draw in CD, which goes from the center out to the circle. That is going to be called a radius. So CD is a radius. So we need to be able to identify those parts, readily, right? So the relationship between the radius and the diameter is that the radius is half of the diameter, right? Because the diameter goes all the way across, the radius goes from the center out. All right, so now that we have a base review of our circles, let's go ahead and talk about arcs and sectors. Okay, so it says relate central angles and arc measures. So because we're talking about central angles and arc measures, right, we are focused on degrees here. So when we find the measure of an arc, we are in terms of degrees. Now, in this picture here, right, we have what's called a central angle. Angle APB is a central angle. The reason that it's a central angle is because it's a circle whose angle is formed by 2 radii. So AP is a radius, PB is a radius, and the vertex is at the center of the circle. Okay, so this is a central angle. Very important idea. Got to be able to identify a central angle. So now, based off a central angle, you can create an arc, right? So there's actually 2 arcs that intercepts. So an intercepted arc is going to be the part of the circle that lies between the 2 segments, rays, or lines that intersect the circle. So typically it's between the 2 radii. So here we have 2 arcs. Right? Now, one of those arcs is called a minor arc and one's called a major arc. It is very important here that a central angle and its intercepted minor arc have the equal measure. That is a huge concept. Huge concept. So make sure you remember that. So in this picture here, a minor arc is smaller than what's called a semicircle. So a semicircle is half the circle. So here in this picture, AB, arc AB is a minor arc. Notice the arc symbol above the A and the B. That's not straight across. It's not AB segment. It's AB with an arc across it, right? This is going to be a minor arc. The measure of that minor arc is the same as the central angle. So if I want to find the measure of arc AB, it's going to be the same as the measure of angle APB, its central angle. So since APB is 95 degrees, the measure of arc AB is 95 degrees. Now a major arc would then be the opposite way, would be going around the figure in the other direction. Okay, it's going to be larger than a semicircle. So notice it's listed with 3 letters, ACB, so you know not to go to AB, but go to A, then to C, then to B. This is a major arc. Now, we need to remember this key idea right here, that a circle has 360 degrees, right? Understand that a semicircle is half of that, which is 180 degrees, so keep that in mind. So in this picture, there are 2 arcs that make up the circle. There's the minor arc and the major arc. So if we know the minor arc's measure, which we do, 95, to find the major arc, to find the measure of arc ACB, let's just take the entire circle 360 and subtract the minor arc AB. So if we take 360 and subtract 95, we get the measure of arc ACB. And the measure of arc ACB will be 265 degrees. So this is how we find arcs, central angles in the circles. Okay, so let's do a problem here. All right, so it's, oh, I'm sorry. So this is going to be your introduction to what or how you find arc measure. So to find arc measure, which again is going to be in degrees, you are going to take the measure of the central angle, and it's going to be exactly the same as the measure of the arc. So in this picture, if I want to find the measure of arc JM, which is this red arc right here, it's going to be equal to the measure of central angle JPM. JP is a radius, PM is a radius, that's your central angle. Again, this is a huge idea. Now a couple smaller ideas, right? So if your central angles are going to be congruent, then your arcs will be congruent as well. So just for emphasis here, so JPK is this angle here, KPL is this angle here. They're marked congruent. Again, they should use staggered arcs, but okay. So they're congruent. So then the arcs they intercept also will have the same measure. So arc JK and arc KL will be the same. They're also congruent. Okay, so that's our talk of arc measure, right? So now we want to use arc measure to find arc length. So example 2, relate arc length to circumference. How do you find the length S of an arc measured in degrees? So we want to find the length S of an arc, and we're in degree mode here. So in degrees is going to be the measure of the arc, okay? Now, we know that the total circle is 360, so this in degrees is part of that 360. To find the length of this arc, the actual walking distance along this curved path, it's going to be related to the circumference. And it's going to be the same fraction as the circumference is. Sorry, the bell rang. It's going to be the same fraction of the circumference as the central angle or the arc measure is from 360. So again, just for emphasis, right? So if it's a fraction of the circumference, then its measurement's not going to be in degrees. It'll be in like feet or inches or miles or meters, etc., right? Some unit of length, right? So here's the formula, right? So first off, circumference. Circumference is 2 pi r. So to find the arc length S, you're just going to take the angle out of 360 times that circumference, 2 pi r. So again, S stands for arc length. So this formula we need to try to put to memory, okay? And sometimes I'll show you that I find the circumference first, and then I multiply by the fraction second. So you'll see as I go through some problems here. All right, so now it says, how do you find the arc length S if it's in radians? Oh my goodness. So this is a new conversation about angles measured in radians. So this is what a radian is. So again, this might be a little bit too much for your class, but we're going to do it anyway. So this box, a radian is equal to the measure of the central angle that intercepts an arc with length equal to the radius of the circle. So the idea is that this degree, right, this angle, not degrees, is formed when you take this radius and you extend that along the arc, right? So again, notice that it kind of bends, right? But this would be 1 radian, all right? So first of all, let's understand if the circumference is 2 pi r, which can be interpreted as 2 pi arcs of length r, right? 2 pi arcs of length r. So this r, we would wrap 2 pi of them around the circle. Therefore, that means that 2 pi radians is equivalent to 360. 2 pi radians is equal to 360 degrees. We also divide this by 2 sometimes, and we use pi radians equal to 180 degrees as a conversion between radian and degrees. Okay. Now you'll see that we're not going to do a lot of radians here, so don't be too concerned. So let's continue this talk and let's actually come up with a formula, right? So what is this formula going to be, right? How do you find the length of an arc S when it's in radians? Well, theta is going to be our radian measured angle, right? Theta, it's a Greek letter, okay? So theta is going to be our angle, which is going to be measured in degrees. So we know that the circumference is 2 pi r. So to find the arc length, right, I'm going to take my angle theta, I'm going to divide it by 2 pi, which is 360, right, but in radian form, right? So this is still the fraction of the circle, and then I'm going to multiply that by the circumference, which is 2 pi r. But the 2 pi's here and here are going to cancel, right? This 2 pi will go up top, it's going to cancel. So the arc length is theta times r, or r theta, whatever you want to do. The angle in radians times the radius, that's all. So this again is your arc length, and this is when it's measured in radians. So the next slide kind of summarizes what we just talked about. So to find arc length, right, if I am in degrees, then to find the arc length, I take the angle or the arc measure out of 360 times 2 pi r, which is the circumference, right? So this formula. And if I'm in radians, I simply take the angle, which is in radians, and multiply by the radius r. Again, this is going to be a lot more used, so be aware of this. And again, just emphasize, right, your arc length, the answer's in feet, inches, miles, meters, etc. All right, so I'm going to stop here. The next video is going to start with an arc length question, and then we're going to get into area of sectors. All right, so stay tuned for video 2.